Welcome in Dark. Astronomers are always looking at the universe and discovering new planets, stars, and other amazing things that blow our minds. Now, scientists have recently found an incredibly bright and mysterious light that's nearly as old as the universe itself. But what is it that they found, and why is the light from this massive object so bright? In 2019, astronomers discovered a 13 billion-year-old light coming from a distant quasar. Quasars are massive and extremely remote celestial objects that emit incredibly large amounts of energy and typically look like a star when viewed through a telescope. But it is what lies at the heart of the quasar's light that's the most impressive. It's said that quasars contain massive black holes and may represent a stage in the evolution of galaxies. And what they found amazed and surprised everyone. A massive black hole that formed so early in the universe that it would have to have an incredibly huge solar mass amount. And mysteriously, it was created 100 million years after the Big Bang. It was given the indigenous Hawaiian name Pinuena to honor its discovery from Mauna Kea. The quasar provides scientists with an idea of what the universe looked like millions of years ago. What can astronomers learn from this black hole, and what does this mean for the future of the universe? The name Pinuena translates to unseen spinning source of creation surrounding with brilliance, and was captured by astronomers using the University of Hawaii's Institute for Astronomy's Pan-STARRS 1 telescope on the island of Maui. The nearly 6-foot diameter telescope is safely stored in the summit of Haleakala. It features the world's largest digital camera with almost 1.4 billion pixels and is a real treasure to employees at NASA. The data was collected by the Pan-STARRS 1 telescope, but it took a lot more than just looking through a telescope to find this massive black hole. The W.M. Keck Observatory provided the near-infrared echolette spectrograph to confirm the existence of Pinuena. The over 32-foot optical infrared telescope includes a suite of advanced instruments, from multi-object spectrographs to integral field spectrometers to a world-leading laser-guide star adaptive optics system. In addition to the near-infrared echolette spectrograph, astronomers also utilized the NIRS instrument in the Gemini Observatory. Once the presence of Pinuena was established by both tools, scientists began to understand the incredible magnitude of this discovery. There's so much more to unveil with Pinuena than any previous quasar. Quasars are known to give off an immense amount of light energy, but Pinuena is especially brilliant compared to those spotted previously. A quasar found in 2018, known by the name J1342+0928, pales in comparison to both the glow and size of Pinuena. Spectroscopic observations unveiled the black hole hosted by this quasar contains a mass 1.5 billion times that of the Sun. That's what makes Pinuena especially unique. It's the only known object in the universe that has a capacity to host a black hole that's greater than 100 billion solar masses. This created another missing puzzle piece in the enigma that is Pinuena. In order for this quasar to grow into such enormous power, it was most likely born approximately 100 million years after the Big Bang. This begs a question: how can the universe produce such a massive black hole so early in its history? Typically, a black hole of such size would grow from a smaller black hole that originated from the destruction of a star. However, Pinuena disproves that such a theory is relevant in this circumstance and instead suggests that the black hole started off as a 10,000 solar mass seed black hole. The creation of galaxies and stars is believed to have begun during the epoch of reionization around 400 million years after the Big Bang. The ionization of hydrogen gas led to the development of the first quasars and black holes. Before the epoch of reionization, there was no source of light present in the universe, since radiation was typically consumed by hydrogen gas. Now, with the confirmed existence of Penelope, researchers have the opportunity to further explore the process of reionization to gain greater insight into the development of black holes. The quasar has been described as a cosmic lighthouse. As its light travels a long journey toward Earth, its spectrum is altered by diffuse gas in the intergalactic medium, which allowed researchers to pinpoint when the epoch of reionization occurred. The massive nature of this black hole is almost entirely incomprehensible, making it difficult to truly comprehend its significance. Scientists are able to calculate the mass of such a black hole by studying the movement of stars in the center of various galaxies. By evaluating the speed of these stars, we can understand the mass of the black holes themselves. These formations grow so large from absorbing immense amounts of gas over billions of years. They consume everything that crosses their path, and their incredible size creates more opportunities for them to swallow up any object in their gravity. As these objects are dragged into the black hole's pool, they are heated to millions of degrees, which results in glowing X-ray light. Nothing can escape the strength of a black hole's gravity. Nothing. However, scientists have only been able to spot a few young cosmos despite thousands of galaxies existing in the closest universe. Since the illumination from the X-ray takes time to travel, studying these areas of the universe requires astronomers to virtually look back in time. There are two main theories as to how black holes are formed. One theory suggests that black holes originated from the first generation of stars. These stars, made up of helium and hydrogen, quickly developed into enormous beings that were possibly hundreds of times the size of the Sun. They did not last very long in the universe, though, and their collapsed cores were all that was left after their inevitable death from titanic supernova explosions. Thus, a black hole was born from their leftover cores. The second theory works off the premise that black holes are not related to stars whatsoever. The first black holes were actually a result of unstable clouds of gas that eventually collapsed. This theory explains how the existence of gigantic black holes can be dated back to millions of years ago. Scientists continue to grapple with these two opposing theories, illustrating just how little we know about the origins of these great bestial black holes. With the largest black hole in the known universe containing a mass 66 billion times that of the Sun, known by the name TON 618, the magnitude of these entities continues to baffle scientists. Fortunately, astronomers are not completely clueless about black holes in our universe. For starters, NASA has determined that it's impossible for a black hole to swallow up an entire galaxy on its own. Although their gravitational pull is quite powerful, it's not substantial enough to ingest an entire universe. No black hole is located close enough to our solar system to pull any object in, but scientists have studied what the potential consequences of falling into a black hole will be by observing stars. While stars that fall into their gravitational pull are ripped apart, humans would experience a process known as spaghettification. The strength of a black hole would stretch one's body vertically while simultaneously compressing it horizontally. Both the perception of time and space are altered when falling through a black hole. While outsiders would only be able to catch a glimpse of the exterior of the mass, the person experiencing the fall would suffer a warped idea of what reality means. With the Sun being the largest star in our solar system, some used to fear that it could explode and create a black hole that would inevitably suck everything into its gravity. But have no fear. The Sun is not large enough to explode and will instead become a white dwarf. Even the hypothetical explosion of this star would not create a black hole large enough to swallow the planet Earth. The Sun's gravitational strength would remain stagnant, meaning that our planet would continue to revolve around it as normal. While we do not have to fret about a black hole consuming Earth anytime soon, the creation of black holes undeniably affects all living things that reside on our planet. When black holes collide, elements such as oxygen and carbon are released into the universe. These elements can potentially contribute to the future creation of planets. Stars and entire solar systems can be formed by shockwaves from stellar explosions that lead to black holes. The connection between black holes and galaxies is still unclear. Astronomers are not entirely sure whether the development of a black hole eventually led to the Milky Way galaxy, or if the Milky Way actually came first. However, it's clear that black holes did contribute in some way to our solar system, even if it's not entirely clear how. This means that everything we know and everything we are is due to the creation of black holes in the universe. Millions of years ago, famous physicist Stephen Hawking determined that though the overwhelming presence of black holes is intimidating, black holes cannot remain in their massive states forever. Known as Hawking radiation, small amounts of energy are lost due to the nature of a vacuum. The vacuum is not actually ever empty, as particles are constantly entering and exiting. When a pair of such particles approach a black hole, one has the opportunity to escape, as the other is sucked into the gravitational force of the entity. The energy that allows one particle to enter space and get away comes from the black hole itself, meaning that the black hole loses part of its mass in the process. Since this process is slow, black holes that make up the universe are expected to remain for millions or billions of years before shrinking. NASA has confirmed that while the black hole in the Milky Way galaxy seems threatening with a mass of a few million times that of the Sun, there is no chance of it consuming the planet Earth anytime soon. At this point, it has swallowed almost all the stars in its gravitational pull. Even if it's able to ingest a few more stars, it only has the capacity to grow in small increments. Galaxy collisions could potentially cause black holes to expand, but it's highly unlikely that these events would disrupt the balance in our solar system. Remember that Penuena is the second most distant quasar discovered. No matter how ravenous and powerful it may be, it remains very far away from Earth. Scientists have finally done what was once thought impossible. They captured the first image of a black hole. But now that black holes have become easier to spot, researchers have found one hiding very close to Earth. Is it dangerous? Is it headed our way? Are there any other black holes out there lurking close to us? In case you're not familiar with these great devourers of the universe, black holes form when massive stars, 8 to 15 times more massive than the Sun, collapse after running out of fuel. Some create powerful supernovae that eject material outward in all directions at almost the speed of light, but some stars simply collapse into dark black holes without a supernova. During collapse, the core of the star begins to compress its gravitational center without ever stopping. The newly formed black hole becomes so dense that its gravitational forces become incredibly strong, pulling in any object that comes too close. The forces of gravity in a black hole are so strong that even light cannot escape it. And now, it's just been discovered that there's a black hole just 1,000 light-years from Earth, located in the Telescopium constellation near Sagittarius. It's the closest black hole to the planet Earth ever found. By comparison, the black hole at the center of the Milky Way is 25,000 light-years away. This black hole might be too close for comfort. While 1,000 light-years might sound distant, in cosmic distances it's very close. It's so close that you can see the star system without a telescope from the southern hemisphere on a dark, clear night with the naked eye. HR 6819 is a triple binary system that is made up of two stars that orbit a black hole. At first, it was thought that this was a simple binary system with just two stars orbiting each other, but after analyzing the data, something very unusual was found about the behavior of the inner star of HR 6819. The velocity of the star was so extreme that the astronomers suspected a third object must be sitting close by, which was flinging the stars around like a slingshot with incredible force. European astronomers finally found evidence for a mysterious large invisible object with a mass estimated to be 4.2 times the mass of the Sun by tracking the two companion stars using the miles per gallon of ESO 2.2-meter telescope at ESO's La Silla Observatory in Chile. To everyone's surprise, it was found that the two stars were actually orbiting a stellar mass black hole around 25 miles in diameter that was formed by the gravitational collapse of a star. The inner star, whose orbit is shown in blue, and the black hole in red look as though they are chasing each other, but they're actually orbiting each other. The inner star completes a loop every 40 days while the outer star travels on a wider orbit. Is this black hole dangerous? Upon further study, the hidden black hole in HR 6819 was found to be one of the very first stellar mass black holes that do not interact violently with its environment and therefore appears truly black. Is it moving towards us? While this black hole is really close to Earth in terms of space, it poses no harm to Earth at the present time and is not moving through space. You may be wondering if there are any other black holes hiding out there just waiting to suck up our solar system. The discovery of the black hole in HR 6819 so close to Earth is just the beginning, and provides clues about where we might find other black holes in the Milky Way. It's estimated there may be hundreds of millions of these universe eaters, and astronomers have spotted around a couple of dozen black holes in our galaxy. But that isn't the first time that a black hole has been found lurking close to Earth. But before we were able to directly image black holes, the only way they could be detected was if the black hole was feeding. This creates a ring of fire called an accretion disk that's caused by heavy gravitational and frictional forces compressing and heating the matter of a star or planet as it falls into the black hole. Before the black hole in HR 6819 was discovered, the next closest black hole to Earth was V616 Monocerotis, which is 3,000 light-years away. V616 Mon is around 9 to 13 times larger than the Sun, and previously you could only see this black hole because it's located in a binary star system that's close to a detectable star that moves in a unique pattern and is orbiting the black hole. Because it has a lot of mass, it has an incredibly strong gravitational pull. Cygnus X1 is another black hole that's close to Earth and is actually considered the first black hole discovered. It was first found in the constellation Cygnus in 1964. It's also famous because the late great astrophysicist Stephen Hawking bet another physicist that it wasn't a black hole, but Hawking lost a bet, and in 2011 it was established as a black hole. Cygnus X1 has 14.8 times the solar mass of the Sun, but only measures 18 miles wide. It lies about 6,070 light-years away from us and is the most brilliant high-energy X-ray source in the heavens. It spins at 800 revolutions per second and is sucking the gas from a closely orbiting supergiant blue star, which is the size of 19.2 solar masses, and is 300,000 times brighter than the Sun. The gas heats as it's getting sucked into the black hole, forming an accretion disk and emitting bursts of high-energy X-rays and gamma rays through jets. Here's a video about what's happening with Cygnus X1 and the super blue giant. Music. For a long time, we could only guess what a black hole must really look like since it's nearly impossible to image an object that light cannot escape from. But technology has been advancing by leaps and bounds, and on April the 10th, 2019, astronomers obtained the first ever image of a black hole located in the galaxy called Messier 87. In the image, you can see the bright halo of gas surrounding the dark object in the center. But it's not just any black hole. It's a monster that measures 24 billion miles across. That's 3 million times the size of Earth and has a mass 6.5 billion times the Sun. It could quite possibly be the biggest black hole that exists. But thankfully, this giant monster is 53.49 million light-years away, or 16.4 million passes from Earth. How the photograph was taken is an incredible feat. Scientists always thought they could image a black hole by capturing their shadows against the glowing surroundings, but this technology wasn't available until now. Everyone knows that the larger the telescope, the greater its ability to gather more light and the higher its resolution will be. So how do you create the largest telescope in the world so it can image a black hole? The team was put together to take on this challenge and created a network of an array of smaller telescopes that can all be synchronized to focus on the same object in space at the same time. They call this the Event Horizon Telescope and have improved upon imaging faraway objects, which is known as a very long baseline interferometry technique. This new powerful telescope is as large as the distance between the two farthest telescope stations. One is at the South Pole and the other in Spain, which created an aperture nearly the same diameter of Earth, about 24,901 miles. This same team is now working on trying to image the supermassive black hole at the center of our own galaxy, Sagittarius A*, which is 4.1 million times the size of the Sun. However, therein lies a great mystery, because for some unknown reason, the ring of fire around the black hole at the heart of the Milky Way is smaller and dimmer. Since we now have the technology to directly image black holes, now there's a good chance we could find them hiding everywhere. There definitely could be a black hole even closer to us than 1,000 light-years. The black holes are still notoriously difficult to detect, which makes them dangerous, because you don't need to be that close to be affected. A black hole can reach out through light-years with its incredible gravitational forces, and if a planet gets too close, it could be obliterated, vaporized, or flung into an entirely new area of space. It's been discovered that black holes like the stellar mass HR 6819 can move. Rapidly moving black holes that are flying through space are essentially impossible to detect because space is very big. Could a black hole be heading our way? The truth is, no one would know until it might be too late. And if you can see stars being warped from a black hole, you're already too close. But for now, there isn't anything to worry about. In the meantime, if you want to try and find HR 6819, use a star map or star map application and find the constellation of Telescopium. It'll appear as a single bright object since the two stars are so close together. Of course, you won't be able to see the black hole itself, but you can know you're staring right at it. As technology and methods improve, closer black holes to Earth will inevitably be discovered. October 4th, 1957. Applause. The first artificial satellite, Sputnik 1, was launched into space by the USSR. Sending the first satellite into space was a breakthrough achievement for humanity and the beginning of a new era. It was also the start of one of the most iconic battles in history between two superpowers. It was the beginning of the space race. As most historians agree, the Apollo 11 moon landing on July the 20th, 1969, that put Neil Armstrong on the moon, put an end to the space race, despite the many successes that the Soviet Union had achieved. But soon everything will change as the world starts a new race in space: mining. Nations all over the world are thinking about mining the moon. China, India, Israel, the USA, Russia, all of them are trying to grab their own piece of the pie. Russia has already warned the USA against colonizing the moon, and now tensions between countries are rising. But is it really worth it? And just what is on the moon that is so precious? It's very possible that the moon could have large quantities of silicon, titanium, aluminium, water, precious metals, and helium-3. Today we'll focus on helium-3 and why it's so important for us. Music. Lunar missions from both the Soviet Union and the United States brought back lunar soil samples, which were found to contain helium-3. The biggest reason we need helium-3 is that it could help free the entire world from dependence on fossil fuels. Having enough helium-3 could help us achieve clean energy produced by fusion power. The most important discovery was a unique atomic structure of helium-3 and that it could be used as fuel for nuclear fusion. A nuclear power plant uses a nuclear reactor to produce heat. The water surrounding the reactor boils, becoming steam, which in turn rotates a turbine that produces electricity. Current nuclear reactors are using nuclear fission, in which uranium nuclei split apart. Besides releasing energy, this reaction is also radioactive, and the radioactive waste which is produced needs to be stored in special secured underground stores. For more than 40 years, researchers have been designing a different type of nuclear reactor, which could potentially provide an environmentally acceptable and safe solution to our long-term energy problems. In these reactors, light gases such as the hydrogen isotopes tritium and deuterium are used as fuel instead of uranium. And when the nuclei fuse, a stable helium-4 isotope, a neutron, and atomic energy are created. This reaction does not produce radioactivity and nuclear waste. But there's a problem with this procedure. The first neutron that produced after the fusion is very difficult to contain and leads to a significant energy loss. This is where helium-3 comes into play. From a helium-3 and deuterium fusion, there is no extra neutron created. Instead, the byproducts are a massive amount of atomic energy and a proton, which is easy to contain and wastes less energy. And on top of that, the helium-3 deuterium reactions do not cause the surrounding material to become radioactive. Nuclear fusion reactors using helium-3 have the potential to provide a highly efficient form of nuclear power with no waste and no radiation. The building of the first fusion reactor has already begun, and in 2035 it's planned to be the world's first fully operational fusion reactor. So we have 15 years to manage the lack of helium-3. But why do we need to go to the moon to extract helium-3? Helium-3 is relatively rare on Earth and is produced from the radioactive decay of tritium, a byproduct of the maintenance of nuclear weapons. But this isn't enough to supply us with what we need. In fact, helium-3 on Earth has a very low natural abundance and a very high production cost. Helium-3 is emitted by the sun through solar winds, but our atmosphere prevents any of this from getting to Earth. Unlike Earth, which is protected by its magnetic field, the moon has been bombarded with large quantities of helium-3 for billions of years by the solar wind. It's been estimated that there are around 1,200,000 metric tons of helium-3 on the surface of the moon down to a depth of almost 10 feet. This makes helium-3 100 million times more abundant on the moon than it is on Earth. And since solar wind gases are weakly bound in the lunar regolith, it should also be relatively easy to extract them. Many scientists believe lunar deposits of helium-3 could provide us with all the power we need for 10,000 years. Researchers estimate that 25 tons of helium-3, which can fit in the cargo bay of one U.S. shuttlecraft, could power the United States for an entire year. This means helium-3 has a potential economic value of about $3 billion a ton, making it the only thing remotely economically viable to consider mining from the moon. The potential benefits of helium-3 are massive, and that's why the largest countries on the planet are planning to go to the moon to get helium-3. The United States' ambitious decade-long Artemis plan promises a human landing in 2024 and the establishment of a moon base that will allow long-duration crew stays for scientific, technological, and economic purposes by 2028. Furthermore, there is an aspiration for a gateway to orbit the moon and serve as a jumping-off point for astronauts who want to explore Earth's natural satellite. This gateway is also envisioned to serve Mars missions in the future. This massive plan will entail 37 launches of private and NASA rockets and a mixture of robotic and human landers. In 2019, the U.S. Space Agency awarded contract to private space tech firms for the construction of a few of the first pieces of hardware that will be required for this colossal mission, such as the Gateway platform and the lunar lander. NASA wants to get back to the moon by 2024 with its Artemis mission, which will cost $35 billion. That's almost 5% of the U.S. military defense budget for 2020. The steep cost of this expedition has been met with skepticism regarding the goal of getting humans on the moon by 2024. For now, the U.S. Space Agency plans to put the first humans on the moon before 2030. Across the Atlantic, Roscosmos, the Russian Federal Space Agency, has been very eager to show the world their ambitious plans for the creation of a lunar orbiting space station and a lunar base. Their plan includes developing a new super heavy booster that can carry up to 113 tons of cargo to low orbits and 29 tons to the lunar pole orbit. The Russian lunar orbit flight is scheduled to take place in 2029, and Russian cosmonauts will officially take their first steps on the moon in 2030, while construction of the Russian lunar base will begin in 2034. Unlike the United States, Russia does not see the potential for industrial utilization of the celestial body. Instead, they claim the role of their lunar station will be used as a defense against comets and asteroids. Not surprisingly, China has been heavily investing in its lunar program while also researching the possibility of lunar mining. Their program took off in 2007 when China sent off a spacecraft to orbit the moon to collect data about the moon geography. By 2013, China successfully completed Stage 3 of its lunar exploration program by soft landing their first probe, U-2. On January 3, 2019, China's second lunar rover, Yutu-2, landed on the moon and is now scanning the moon's far side. Incidentally, China was also the first country to grow a plant on the moon inside the Chang'e 4 probe on January 7th. You can check out that video here, or you can find that video link in the description. In 2019, the Chinese National Space Administration talked about their interest in building a lunar base of their own on the south pole of the moon in about 10 years, while also planning to send off their first crewed mission before this. The scale and timing of China's lunar program can only highlight Beijing's ambition to rival the United States and Russia as a space power. There's a big question regarding this. Who really owns the moon? The Outer Space Treaty was signed in 1967 by the United States, Russia, and several other countries. The Outer Space Treaty doesn't ban military activities within space, military space forces, or the weaponization of space. However, it does prohibit the placement of weapons of mass destruction in space, including nuclear weapons. It also limits the use of the moon and all other celestial bodies to peaceful purposes only. It states that space should be free for exploration and use by all nations, but that no nation may claim sovereignty of outer space or any celestial body. It's mostly a non-armament treaty but has no real regulations when it comes to lunar and asteroid mining. Who will be the first to go to the moon and successfully mine it? Only time will tell. For now, we need to understand the future, and that future is coming right now. In a decade or so, space mining will become a reality, and all of us will witness history being made. It will be the beginning of a new age in humanity's history. Since the discovery of the telescope, astronomers have made huge steps into understanding the origin of the known cosmos. However, even after so many years, we're finding things in deep space that no one has seen before. On June 26, 2020, something mysterious occurred when 4 strange objects were identified by the Radio Telescope Australian Square Kilometre Array Pathfinder. These seemed unlike any other astronomical objects ever seen before and ignited a spark of interest in the astronomical and space community. The first 3 objects were spotted in the depths of space using a pilot survey of a new project called the Evolutionary Map of the Universe, while the 4th object was retrieved in archival data, which were collected by the Giant Meter Wave Radio Telescope in India and helped to confirm that the first 3 were not just lens anomalies. The objects distant from our solar system is still unknown, but one thing is certain. They are not located in the Milky Way's galactic neighborhood. Each object was calculated at around 1 arc-minute across. Keeping in mind that, as seen from Earth, the Sun and Moon both have angular diameters of about 30 arc-minutes, the 4 unidentified objects are highly circular with bright edges and look like distant ring-shaped islands. Because of their strange shape and peculiarity, they were characterized as odd radio circles, arcs for short. It seems that arcs might have different origins. All of them were visible in radio wavelengths, but completely undetectable in visible light, infrared light, and X-ray light. 2 of them have galaxies at their center, which means they might have been formed by them, while 2 of the arcs might have some kind of interconnection or even the same origin since they seem to be in close vicinity. There are several possible explanations of what those arcs might be, but none of them seem to fit perfectly the object specifications and characteristics. The astronomers already ruled out description for those orcs, objects like supernova remnants, planetary nebulas, circumstellar shells, star-forming galaxies, or even the possibility of gravitational lensing. But the EMU survey is just beginning, and astronomers expect it to reveal more unusual objects as time goes by. Speaking of strange space objects and unsolved mysteries, we don't need to go very far to find a celestial body to draw the astronomers' attention. If we look inside our very own solar system backyard, we will find Haumea, a dwarf planet which is found in the Kuiper belt beyond Neptune's orbit. Why is it a strange planet, you're asking? Well, a day in Haumea lasts only 4 Earth hours, making it the fastest rotating large object of our solar system. Actually, it's rotating so fast that scientists argue that probably this is one of the reasons for Haumea's weird shape. This planet is not spherical, as you would expect any planet that respects itself to be, but instead looks a bit more like a football since it's more or less twice as long in one direction as it is in the other. Haumea is 10 times smaller than Earth with a radius of about 385 miles and has 2 moons, Namaka and Hyakka. Due to its distance from the Sun, almost 43 times Earth's distance from it, one orbital period is approximately 282 Earth years. But a recent discovery made Haumea an even more interesting space object. It appears that this hobbit-sized planet's equator is encircled by a 43-mile wide ring of debris located about 620 miles from its surface. This discovery, in combination with Haumea's unusual features and the trajectories of several Kuiper belt free-roaming objects, gave the astronomers a very good indication of what happened with this dwarf planet. According to a mathematical model, it looks like a large Kuiper belt object smacked at some point the younger and larger Haumea. The dwarf planet's ring and moon seem to be fragments of that collision, which also seems responsible for its fast-paced rotation. This is still a theory regarding Haumea, but it seems to fit the bill very closely. If we go a bit further, just a mere 20 light-years away from us, we can find the planet SIMP 0136 in the constellation of Pisces. This planet has given the scientists a good head-scratching since it was discovered to have such a strong magnetic field that, in an imaginary arm wrestling competition with Jupiter, SIMP 0136 would win as if it was wrestling against an ant. You see, it has a magnetic field more than 200 times stronger than Jupiter's, which, as a reference point, has a 16 to 54 times stronger magnetic field than the Earth. The planet forms the most spectacular auroras, and astronomers don't really know the reason behind this, but hopefully we'll know in the near future. Furthermore, this planet is of even greater interest to the scientists because it's exactly at the boundary between a planet and a brown dwarf, or as it's also called, a failed star. This characterization means that this planet is quite large at about 12.7 times the mass of our solar system's biggest planet, Jupiter, but not quite large enough to fuse hydrogen in the way stars do. Under further investigation, it was discovered that SIMP 0136 is actually a youngster brown dwarf of only 200 million years of age and is traveling the cosmos on its own without an orbit around a star. The scientists hope that SIMP 0136 will give them answers regarding the magnetic dynamo mechanisms of planets beyond our solar system and that, with the help of their radio telescopes, they'll discover more planets with such distinctive auroras. One of the greatest problems in cosmology is that of dark matter. Well, this has nothing to do with black particles or any sinister type of material that destroys celestial objects. Dark matter, or as we initially called it, missing matter, is a type of material that cannot absorb, reflect, or emit light and cannot be detected by observing electromagnetic radiation. This means that it's extremely difficult to detect, and astronomers can only identify it by observing the gravitational effects that it has on other visible objects. One of the leading theories is that dark matter is made up of some new kind of subatomic particle that we haven't discovered yet. Even though undetectable, dark matter is extremely essential since it acts as a glue that keeps the visible matter of all known galaxies together. Astronomers estimate that dark matter accounts for 85% of the matter in the universe and about 25% of its total mass energy density. This is a lot, and it means that dark matter exists almost everywhere. Keep that thought for a second. In 2018, a team of astronomers announced that they've discovered the first known galaxy which contained an amazingly low amount of dark matter, almost zero. Its name, NGC 1052 DF2, or the more convenient DF2. This 10-billion-year-old galaxy is 6.5 million light-years away from our solar system, and is more or less the same size as our Milky Way but contains 200 times fewer stars. Because of that, DF2 is classified as an ultra-diffuse galaxy, meaning it has low luminosity and detectability. How did the scientists find out that DF2 has very little levels of dark matter? Well, we said that dark matter affects the movement of planets and other celestial objects. We know it's there because without it, there's no way of explaining the trajectories and velocities of planets. The galaxy DF2 defied expectations when scientists discovered that several star clusters inside it were moving at speeds consistent with only the mass of the observable normal matter. Upon closer inspection, DF2 was found to contain at best 1/400 the amount of dark matter astronomers had expected. Another reason DF2 stands out as an oddball galaxy is its shape. It lacks a noticeable central region and shows none of the usual characteristics of a spiral galaxy, such as spiral arms or disk. It also doesn't resemble an elliptical galaxy, and there is no evidence of a central black hole, only a stellar halo and several globular clusters. Everything about DF2 seems strange and defies modern theories. Interestingly, the same team of astronomers soon discovered another galaxy with similarly low dark matter concentration, NGC 1052 DF4, DF4 for short. Before this, every known galaxy contained dark matter, making these discoveries groundbreaking. They may help us understand how dark matter-less galaxies work and uncover more about the mysteries of the cosmos. In 2018, a dwarf galaxy named Bedeni was discovered just 30 million light-years away, practically in our Milky Way's neighborhood, considering the observable universe spans 93 billion light-years. Bedeni is categorized as a dwarf spheroidal galaxy because of its small size, low luminosity, dustlessness, and old stellar population. It's tiny, spanning only 3,000 light-years across, compared to the Milky Way's 100,000 light-year wide spiral disk. Furthermore, it's located about 2 million light-years from the nearest larger galaxy, making it the most isolated dwarf galaxy known. Its isolation means it hasn't interacted with other galaxies, preserving its original structure. Bedeni is also estimated to be about 13 billion years old, making it as ancient as the universe itself. This makes it a sort of cosmic fossil from the early universe, potentially holding untold secrets. When it comes to space's unanswered mysteries, one thing is certain: we have much more to discover. Now, a quick question for you, dear viewers. Having seen some of the strangest celestial objects known to science, what do you think is still lurking out there, waiting to be discovered? Our Milky Way galaxy alone contains hundreds of billions of planets. From Earth, perched on one of its spiral arms, we had just begun peering across the cosmic void. Recently, scientists discovered the first Earth-sized planet located in a star's habitable zone. NASA's exoplanet program was created to seek out unmistakable signs of life on other planets. In the process, some truly bizarre alien worlds have been found. One of the most fantastical is PSRJ 1719-1438, a neutron star, an extremely dense stellar object about 12 miles wide. A teaspoon of neutron star material would weigh 1 billion tons on Earth. PSRJ 1719-1438 is a millisecond pulsar, spinning at 10,000 rotations per minute, and it is an astonishing companion. A planet roughly the mass of Jupiter, but only 40% its size. Scientists believe it is a remnant of a stripped-down star composed of crystalline carbon, essentially making it a giant diamond planet 5 times larger than Earth and far denser than any diamond found here. Another mysterious planet, HD 189733b, orbits just 63 light-years from Earth. Discovered in 2005, this planet is deep blue, not because of oceans, but due to its blowtorched atmosphere filled with silicate-laced clouds. It endures temperatures of 2,000 degrees Fahrenheit and 4,500 miles per hour winds that might cause molten glass to rain sideways. It's only 2.9 million miles from its parent star and is gravitationally locked, with one side always facing the star. In comparison, Mercury is 29 million miles from the Sun. TRAPPIST-1, an ultra-cool red dwarf discovered in 1999, lies about 39.6 light-years from the Sun. NASA found the first Earth-sized planet in its habitable zone, Kepler-186f, in 2014. By 2015, 7 rocky, Earth-like planets were found orbiting TRAPPIST-1. These planets could hold up to 250 times more water than Earth, and are so close together that one would be visible from the surface of another. However, the TRAPPIST, one star emits only 0.5% of the Sun's energy, and the planets are cold and dark despite their habitable zones. In 2020, NASA discovered a planet similar in size and distance to Earth from its star, about 13,000 light-years away. It's an icy world with likely no life, possibly orbiting a brown dwarf. But even in our solar system, there may be life. Saturn's moon Titan is a prime candidate. Titan is larger and more massive than Earth's moon, and it has an atmosphere with rain, lakes, and oceans, though not of water, but of ethane and methane. With a nitrogen-rich atmosphere and temperatures around -290 degrees Fahrenheit, Titan's environment is extreme, yet its organic chemistry and possible internal warmth make it a key candidate for life. Titan may house biologically interesting compounds like amino acids. NASA plans to explore it further with Dragonfly, a nuclear-powered quadcopter drone launching in 2026 and arriving in 2034. It will explore diverse locations and ultimately reach the Silk Crater, believed to host the ingredients for life. As the Sun evolves into a red giant in about 5 billion years, Titan could warm enough to have stable liquid water on its surface, potentially allowing exotic life to thrive. This warming could last long enough for life to evolve, just as it did on Earth. In early 2020, NASA's test discovered TOI 700d, an Earth-like planet in the habitable zone. Though little is known about its exact conditions, the James Webb Space Telescope, launched in 2021, will offer far more advanced infrared resolution than Hubble and may help confirm signs of life. Covered in pure gold and costing $10 billion, this telescope can image the earliest galaxies and analyze exoplanet atmospheres. Its ability to detect oxygen could finally reveal planets with life. So far, over 300 million potentially habitable exoplanets are estimated to exist in the Milky Way alone. Kepler's mission helped identify thousands before its 2018 retirement. While direct imaging is rare, methods like transits, spectroscopy, and gravitational lensing have uncovered many new worlds. Some are considered super-habitable, better suited for life than Earth. Criteria include size, age, warmth, oxygen levels, and orbiting stable K-type stars. These stars live up to 70 billion years, giving life more time to evolve. Gliese 667cc and Kepler 452b are such worlds. The latter, also called Earth 2.0, orbits a Sun-like star 1.5 billion years older than ours. In October 2021, the James Webb Telescope launched to detect atmospheric oxygen through a unique collision signal. This could be a breakthrough in finding alien life, but it will only work for Earth-like atmospheres within 16 light-years. To look even deeper, NASA is preparing the Nancy Grace Roman Telescope, launching in the late 2020s. It will have 100 times the field of view of Hubble and can directly image exoplanets and probe dark matter and energy. It will focus on the Milky Way's interior using gravitational microlensing, likely revealing thousands more exoplanets. Ultimately, life may exist in forms we don't yet imagine, and some of the best places for life may look nothing like Earth. With these powerful new tools, we are entering an exciting era of discovery, and perhaps the first undeniable signs of life on a distant world. Thank you for watching Dark Core.